Okay, we are now doing the second half of the naming both ionic and covalent compounds worksheet number 3. And this time we're taking the name and we're putting it into the chemical formula. Alright, so you see for number 11, you see the prefix there. That's an automatic indication that it's a molecular compound. So that means we do not care about the charges on these. So silicon is Si, because there's no prefix in front of it, that's just a 1. Dioxide, oxide is oxygen, and di means that there's 2 of them. And that's all you have to do for number 11. Number 12, nickel 3 sulfide. That 3, if we look on the periodic table, we find that nickel is actually right here. You can't determine the charge of nickel simply by looking at the periodic table. That's why they give you that Roman numeral 3. That's telling you that nickel is a plus 3. So it's Ni plus 3. Sulfide is sulfur, and you can look on the periodic table, and it's right here. It's in the row that says minus 2. So that means it has a minus 2 charge. Crisscross those numbers, it becomes Ni2S3. Manganese 2 phosphate. Once again, manganese is right here on the periodic table. You can't determine the charge of manganese just by simply looking on the periodic table. That's why they give you the Roman numeral 2. It's telling us that the manganese has a plus 2 charge. So it's Mn plus 2 charge. Phosphate is PO4, and that has a minus 3 charge. That's a polyatomic ion, and it will always be a minus 3. So we're going to crisscross those charges, and it becomes Mn3 crisscross outside of the parentheses, PO4 2. Silver acetate. Silver is one of the 2 transition metals that actually do not change their charge. Ag is here, and zinc is here. Ag is always a plus 1, and zinc is always a plus 2. Because of the fact that they don't change their charges, we don't need to have a Roman numeral there. So Ag has a plus 1 charge. Acetate is C2H3O2 with a minus 1 charge. So we're going to crisscross the 1 and 1, and because it's just 1 and 1, I'm not going to bother rewriting the parentheses or the 1s. Number 15. 15, once again, we have a prefix here. We have 2 prefixes, diboron, tetrabromine. So diboron is boron, and di means 2. Tetrabromide, bromide is bromine, and there's 4 of them because it's tetra. This polyatomic ion we have not talked about, but that basically means it's sulfate. The heptahydrate means that hepta is 7, hydrate is water. But it's still sulfate with a negative 2. Magnesium, when you look on the periodic table, there's no prefixes here, so we need to look at the charges. Magnesium is here on the periodic table. It has a plus 2 charge. And sulfate is SO4, has a minus 2 charge. That becomes Mg2SO4 2. Because it's 2 and 2, they reduce down to MgSO4. The 2's and 2's cancel. .7H2O. You would not have to know that, though. Potassium carbonate. Carbonate is a polyatomic ion. Potassium's a metal, carbonate's an anion, so potassium becomes a cation and carbonate becomes an anion. And because of the cation anion, it's an ionic compound. There's no prefixes, so that means we do have to concern ourselves with the charges. Potassium, if you look on the periodic table, is a +1 charge. Carbonate is a -2 charge. You crisscross those, K2CO3. Because of the fact that this is a 1, I can just write it K2CO3. Ammonium is a polyatomic cation. It is NH4 with a +1 charge. Oxide is oxygen. By looking at the periodic table, we see oxygen's right here. It has a -2 charge. So NH4 with a +1 charge and oxygen with a -2 charge, we're going to crisscross it. Becomes NH4 2O1. Number 19, 10-4. If we look at the periodic table, we find that 10 is right. Where's 10? Oh, there it is. It's in the same row as carbon. I thought it was there. I couldn't find it. Because it's in a row that has a lot of different charges, they ended up having to tell us what the charge is. So SN, that 4 means it's a +4 charge. Selenide is selenium. That's Se. And if we look on the periodic table, we find that it's right here in the -2 row. So that means it has a -2 charge. So that means SN2Se4. Now the 2 and the 4 can be reduced to be SNSE2. They're both divisible by 2. And finally, we have carbon tetrachloride. We have a prefix here again, so that's going to tell us how many we have. Carbon, because we have no prefix there, it's going to be a 1. Tetrachloride. Chloride is Cl. Tetra means 4, so CCl4. And that is the end of the naming both ionic and covalent compounds worksheet number 3.